and thank you to be there. I'm very happy to present you a little story that started from a basic challenge that can happen to everyone. And finally, with this challenge, we managed to get some great idea and some great product. I've seen some familiar faces in the audience, but today you are much more as last year in Munich. So for those who don't know me, I'm Matthias Mertens. I'm working in the cloud enablement team of our company. Our team is responsible for providing cloud accounts or cloud subscriptions to our internal product teams. If some team inside our company wants to run an application in the cloud, they have to come to us and we provide them the account itself with all the requirement infrastructure already ready. On the other hand, we are also responsible for promoting the usage of cloud technologies within the company, and we are helping other teams and providing some consulting services if they need to help them in their journey. About Helvetia, it is a Swiss insurance company founded in 1858 in St. Gallen, and we are quite strong on the market in Switzerland, but we also have some branches around Europe, in Germany, Austria, Italy, France, and we are also in Spain, where we are also quite strong. Besides this, we have a small specialty market worldwide. Our story here begins in Spain in one of our company called Caser. At that time, they were really at the beginning of their cloud journey, and they came to us with some challenge that they had and asked for some help. So, what did they want to do? They wanted to provide an online insurance conclusion tool to allow their customers to get some have some insurance, but for this they need to validate the ID provided by their customers to be sure that they are who they pretend they are. For that, they decided to use a tool which is provided by a company called Veridas, and this company is one of the leaders in identity verification. This company is providing some SaaS version of the tool, but there, for some compliance reasons, it was not possible to use this SaaS version, so they needed to have some self-managed installation of that software. So they came to us for asking for advice, and we checked together what are the requirements that they had. So this vendor provides the tool as a container image only. It can be deployed on a virtual machine running a container runtime, but for some, in my opinion, obvious reasons, they do not advise to run this in production, and it's good for testing and to evaluate the software. For the production version, they advise to deploy it on a Kubernetes cluster that would be available, and they also provide the YAML files with the pods and the definitions for all the Kubernetes assets that are needed. On the side, this software also needs some persistent storage to store the images of the ID provided, and some relational database to put all this together. For this, they also provide some YAML definition files to be able to deploy a Postgres database and persistent storage on the Kubernetes cluster. The problem that we had there is that there was no Kubernetes cluster available for the team that requested this, and they had no knowledge about this, which means that they were not able to deploy and manage themselves a Kubernetes cluster, and deploying some YAML files that you receive from a vendor without understanding what you are doing, especially when it's regarding databases and persistent storage, can become a disaster. About our internal IT strategy and considerations. So this is our cloud strategy, and this strategy is the base of most of our successes. It is cloud first. In Switzerland, we migrated everything to our two cloud providers that we have, AWS and Azure, and we are closing all of our data centers. our branches abroad still have some data centers, but as we are starting a brand new project, it would not fit our strategy to try to see if we could deploy them on premises there. On the other hand, we are an insurance company. We are not an IT company. This means that our core business is insuring. It's not developing some products. So that's why we prefer using software as a service over product as a service over infrastructure as a service, because we then shift left the complexity and let people for who it's their core business to manage the infrastructure and all the hassle with that, and we can focus on our core business. On the other hand, it may also be cheaper to use SaaS products. Here, as a side note, but it's important for later on, some of the cloud provider tools, as example, for example, CloudWatch, could be from Amazon, could be considered as a SaaS product because it's working out of the box without needing to maintain and operate anything to use that. The advantage of this kind of tools is that we already have some contracts with AWS and Azure, which means that when looking for some other tools, we don't have to go to all heavy procurement processes that we may have. Regarding the operational constraints, of course, our team there had not a lot of resources to operate and no time for that. It should, of course, not cost too much. And when we asked about the timelines and the deadline, the answer was, as most of this kind of projects, it would be good if it will be finished yesterday. So we did not have so much time to find some fancy solutions. Within Helvetia, in Switzerland, we have some development platform which is based on OpenShift and that we could have considered to use for deploying this, for running this container. The thing is that this platform, this team is doing a great job, but it's a development platform which is meant for self-developed code and with all the tools developers need to write and deploy code. So it would have a little bit overkill to use this. Also, this platform is meant for our Swiss market, and we would not have some time to convince and open this platform to our international teams. So this is why we could not use this product. So we were thinking, with all this said, can we try to use cloud provider native tools that we could use out of a box to deploy our solution here? So, answer is yes. We looked a little bit around and we found that for deploying, running the container, we could use Elastic Container Service Fargate, called ECS. For the persistent storage, we could use EFS, Elastic File System from Amazon, and for the relational database services. We tried to select only products that we don't need to manage. So, if possible, serverless products. Here, the RDS is still. There is still a server behind, but as it's completely managed by Amazon, it was okay with our needs. That's good. Here we have the tools needed for the base requirements. But we want to have a production-grade scalable installation, and we could not just run a container, deploy a database and a file system, and let's go. We needed some surrounding services. So what about where to store the container images? What about the secret management, the SSL certificates, the domain name, the load management? This tool needed to send some emails also, and we needed to store the logs. Could we find some services provided by AWS which fulfills all our needs? So, for all of these needs, we found a product which is Elastic Load Balancer for the load, Fargate, EFS, and RDS, we saw it. Route 53 for the DNS, Certificate Manager for the certificates, Container Registry to store the images, Simple Email Services, Secret Management, and CloudWatch for the logs. So we presented this to our team, and they were quite happy and were okay to go forward. But now, how can we deploy this and how to maintain and operate this? Because this team knows a little bit what AWS were. They could click a little bit around in the portal, but it was maybe they were not feeling so comfortable to do that themselves. On the other side, in Spain, Helvetia has two companies. One is Caser, that we were talking about, and the other one is Helvetia Seguros. Even if there are two companies, the IT departments, these guys are talking together. And when the first company said to the second one what we were doing with them, they came to us and said, can we have the same, please? So we had to find a solution which could be easily reusable. That's why we decided to use infrastructure as code to automatically deploy the environment, the resources that we needed, and reuse it among different environments, integration, production, and also among different companies, here Caser and Helvetia Seguros. It was very easy to modify the slight configuration differences between them, between the integration environment and the production, and between these two companies with the variables. This also allowed us to remove most of the access rights on the console so that they could not go log in and try to modify things by hand without informing anyone and creating some outages that we would need to investigate. As a financial company, we are also having a lot of audits, and when an auditor comes and asks us who did what and when, as we are storing the code of this infrastructure in a version control system, and that is deployed from this VCS, it's quite easy to show them, yes, this is a Git history, you can check who did what and when, and it's automatically deployed from them. It's out-of-the-box audit trail. We decided to use Terraform as it's a well-known community-based and enterprise-level product, and that we, as in our team, we are using it already because our strategy being multi-cloud, we wanted to have one tool for both of our clouds, and here Terraform really fulfilled all our needs. So, what does this mean for the team? They had no patching, no maintenance of the underlying infrastructure. Everything was managed by AWS. There is not a lot of upfront sizing. They didn't have to choose what Kubernetes nodes or how many nodes and what are the size of them. This is also managed by AWS. Elastic File System being theoretically infinite storage. They don't have to check if the disk will be full and create an outage. And the logs are automatically saved and forwarded in CloudWatch. The only operational task that they have is if the vendor releases a new version of this product, they have to get the container, upload it to the container registry, and change one single line of code in the configuration variables, committed to Git, first to integration, then to production, and everything is automatically deployed. They were quite happy about this, and they were amazed how fast we could bring this to live. And first thing, they started to invest in knowledge in Terraform, which was, in our case, quite good, because we like that people do cloud right from the beginning, and using infrastructure as code and automation from the beginning is the right way of doing. And then we took a little step back and were thinking, what we did here, we invested some time. Can we reuse this? Can we try to make a product around this to be able to deploy third-party container in our environment automatically? And yes, we can. What we want is that a customer, an internal team, should provide us a container image, select if they want a database and if yes, which one, select if they need storage, and if it's production, select if they need backup, and then we make a solution to deploy this in the same way. We have some constraints as a big company. We need to use all our corporate tools. So our ITSM tool being ServiceNow, we needed to use this as a main entry point. And we needed to provide a form that customers could use to order our service. On the other hand, as said, our strategy being multi-cloud, we need to find a solution that works for both clouds. Generally, we are choosing which provider depending on the needs. For example, if the product would need a Microsoft SQL database, it would make sense to use Azure. Here, as we already started with AWS, we did the first version with AWS, but by doing the architecture of this, we had to keep in mind that we need to do it for Azure later on. So here would be the target architecture of our system. We first have a central networking hub account where we have the transit gateway and all our cloud accounts, not only the ones which are meant for this container management service, but all our customers have a transit gateway attachment going to this one. The central DNS is also there. Then we have another account which is specially meant for the management of this container service, and this one contains the registry, the subzone of Route 53 for the DNS, and also all the automation which is around our system. For the application themselves, we decided to have one Amazon account per application because it's more easy than for rebilling to have everything just in one account and just one application per account, and also for segregations of permissions and separation of duties, it's easier to have one account for that. The design that you see here is slightly simpler than the one that we did for our colleagues. It's because we focused on the main use case and decided to not have too much edge cases to fill most of our customer needs. So, at the end, what does our customer need to do? First, they need to get a container image, or they get them from a vendor and upload them to our internal registry, which is Nexus, or they can select publicly available image, which would be available, for example, on the Docker Hub. Then they need to fill in a snow form with names, reference to the container image, the size. We still need to know if we need how many CPUs and how many memory we need, how many containers, which port are exposed, database, file system, do we need backup. When the snow form is submitted, it will call a webhook, which will trigger an AWS step function, which will first create a new AWS account. We are using Terraform to create the AWS account and then to deploy all the base infrastructure, which we call the landing zone, which is available for all our customers, not only the one who needs the container. When this is finished, the step function will then create another configuration file in our version control system, which will trigger another Terraform workspace, another Terraform run, which will deploy the infrastructure that I presented before. This looks great. But we have to think about that we are dealing with humans, and humans stay humans. If we let them choose anything, they will also always go for the worst. And we had to think about vulnerabilities in the container image, variables, secrets, sizing, and scaling. So about the registries. Our people could I don't know, download some containers that they found on the internet, available somewhere, and just let's test it and run it in our internal infrastructure. Why not? They could also find someone which is available on the Docker Hub without really checking and knowing what they are doing. So we want to be sure that these container images do not contain any vulnerability. So we found a nice Terraform provider which allows us to copy over images from other registries to Amazon Container Registry, and there we configured scan on upload, which means that we could block the process in case we found any vulnerability. Then we wanted to prevent our customers to just put some secrets directly in the Snow form by why our Snow deployment is not meant to manage secrets. And if we let people putting everything they want, of course, at some point, you will have some team which will put secrets there. And this is something that we wanted to prevent. So we decided to limit as much as possible the inputs that they could put in the Snow form, and we decided that they could only select where to store, in which environment variables, the database configuration string, and what is a mount point for the storage. It's possible that some software needs some variables or some secrets in environment variables, and our backend is supporting this, but if they need that, they have to contact us, and we provide a secure way to transfer these credentials to us, and we can then configure the system for this. Last but not least, as a customer, as a human, if you receive the specifications from the vendor and decide to check what are the size of what you need to deploy, how many CPU, how many memory, what will they do? Take the requirements, check the numbers, take the double, and then deploy, and then select that. Why? Just because we want to be sure. And at the end, it's maybe it's not their money, it's company money, so it's not a problem. If they have no idea about what is the size, they will just take the biggest one because it is possible. So we work together with our FinOps team, and we checked what we can do to avoid over-provisioned infrastructure. So here, we decided to give some t-shirt sizes, predefined sizes with CPU and memory, and let them choose between S, M, and L. If they need more, they have to come to us, and we assess it, and if it makes sense, we can then create a larger instance for them. On the other hand, we are closely monitoring the usage of the compute power to be sure that if it's oversized, that we are automatically scaling it down based on the load to avoid losing money for nothing. So with that, we were able to address the issues that we found. But there are still some things which need to be done, and how to continue with that. It's about backups. The backups are done automatically by the system, but currently the restore is still a manual process, and we would like to automate this. Updating the database engine. The bug fix versions are automatically updated by the cloud provider, but if we need a major or a minor update, this includes some manual process that we would like to avoid. And as you may have seen, the secret management is not yet optimal, and it would be nice to make this better. At the end, what I wanted to say is that we started with some very basic use case, some small problem that some team had, and taking a step back, looking what we could do, getting experience from our errors, we were able to find a new product, a great opportunity to make things better just by starting from something small. So my final message is, always check for opportunities if you are facing this kind of issues. I thank you for your attention, and if you have some questions, discussions, I will be later on around during the coffee breaks and so on. Thank you very much.